Htio sam se četiri da smo čuli kako se ne znam da li se već svala ili ako nije svačila, sad ne znam.
Znamo koliko
Ja sam
danas se to čuli.
hvala već.
Tako je dogovorili.
Ali sam dogovoriti te termine kako će šta ići lijepo. Ja sam nas učio, ali nisam pogriješio.
Niste, mi smo se čuli negdje.
Pa dobro, ovako nije nam ništa kipno, ali ja sigurno ja mislim da možete izaći napade, ali hoće sad.
Ladies and gentlemen, dear guests, on behalf of the Faculty of Technology Zvornik, University of East Sarajevo, and the 7th International Congress, Engineering, Environment and Materials in Process Industry, EEM 2021, allow me to extend a warm welcome to the Vice Rectors of the University of East Sarajevo, Dr. Marko Gutelj, Vice Rector of the for International Cooperation and Quality Assurance, and Professor Sandra Ivanovic, Vice Rector for Student Affairs, Culture, Arts and Sports. Representatives of the co-organizing institutions, distinguished deans, professors and students attending this event, all the participants of the Congress, representatives of the sponsors, the industrial sector and the business entities and local communities, representatives of Happy Travel Tourist Agency from Bijeljina, the staff of the Termak Hotel Jahorina, representatives of the media. Ladies and gentlemen, distinguished members of the Scientific Committee, dear guests. The International Congress, Engineering, Environment and Materials in Process Industry, held every 2 years, has been listed as the first category international scientific congress, according to the ranking given by the Ministry of Scientific and Technological Development, Higher Education and Information Society. This international academic event was established 12 years ago, and we are proud to say that so far almost 1,000 researchers and professionals from over 60 countries have taken part with over 1,300 submissions. We therefore wish to thank all those who have participated in the events organized for these past 12 years. We owe our gratitude to all the authors for their submissions, to the researchers, academics, and associates for all the results we have achieved together for the past 12 years. We also wish to thank the members of the administrative and technical personnel for their help so far. On behalf of the organizing committee, I would like to extend our warm welcome to everyone of you sitting in this room and welcome you all to the 7th International Congress, Engineering, Environment and Materials in Process Industry, EEM 2021. We thank you all for taking time out of your schedule and joining us for this event. We would also like to extend our very warm welcome to all the people who are not in this room, but who are accessing the event via video conference. The goal of EEM 2021 is to bring together researchers and practitioners from academia and industry to focus on research advancements and innovations and establishing new collaborations in the area of chemical and electrochemical engineering, food engineering and biotechnology, environmental engineering, materials and material characterization, nanotechnology, inorganic chemistry and technology, organic chemistry and technology and polymers, plasma technology, energy efficiency and renewable energy sources, textile engineering, corrosion and protection of materials and thermal power plants, metallurgy, management in the process industry. We wish to thank all the attendees for their decision to take part in this event and their enthusiasm for the exchange of research results and innovative ideas among their peers, as well as for the passing of knowledge to younger generations. We hope that some of these results will bring about the positive changes in our lives and ultimately result in the advancement of our society as a whole. Ladies and gentlemen, I now invite the working presidency to take their seats. Professor Dr. Dragan Vujadinovic, Dean of the Faculty of Technology Zvornik, University of East Sarajevo, and Chairman of the Organizing Committee. Let's greet the Dean President. Professor, please take a seat. Professor Dr. Svetlana Pelemish, Vice Dean for Science and Research of the Faculty of Technology Zvornik, University of East Sarajevo. Professor Dr. Genji Vashtag, Department of Chemistry, Biochemistry and Environmental Protection, Faculty of Sciences, University of Novi Sad. Thank you all. I now invite the chairman of the organizing committee and the dean of the Faculty of Technology Zvornik, University of East Sarajevo, Professor Dr. Dragan Vujadinović, to address the conference. Dean Vujadinović.
Thank you. Ladies and gentlemen, good afternoon. Honorable Vice Rectors, representative of the University of East Sarajevo, representative of local communities, sponsors, participants at the EEM2021 Congress, fellow teachers and researchers, distinguished guests, ladies and gentlemen, welcome. On behalf of the organizational and scientific committees and myself personally, I would like to give our warmest greeting to all of you. I would like to thank you for attending this opening ceremony here at the Terman Hotel and to all those who are following this event virtually. We are delighted to welcome all the scientists and professionals participating at the 3 days hybrid event. We would also like to thank the organizations and individuals for their telegrams and emails with the best wishes for the successful of this scientific event. Ladies and gentlemen, the International Scientific Congress, Engineering, Environmental and Materials in Process Industry EEM 2021 is held on the beautiful mountain Jahorina every 2 years. As you all know, for more than a year, we have been faced with the new reality, the reality of the COVID-19 outbreak. We have been forced to adapt to the unprecedented change in a society level, many with a sense of physical, social, and economic vulnerability and uncertainty. It goes without saying that we all wish we were gathering under very different circumstances. However, as a scientist, we must look at these challenging times as an opportunity to reinvent the sense of meaning and importance of the work we do, to open ourselves up to new ideas and build up new concepts and connections. This is the first Congress in the history of our institution, Faculty of Technology Zvornik, which is conducted as a hybrid event, both in person and on digital platform, in line with the social distancing norms due to COVID-19 pandemic. The EEM 2021 Congress has gathered eminent researchers and professionals from over 30 countries. A total of 228 papers have been submitted, and the field of greatest interest are chemical engineering and technology, food technology, biotechnology, materials, and environmental science. We are proud to see such an eagerness and diligence in the academic community, and we feel inspired by the willingness to come together and bring about a solution for many problems the world is facing today. In the age of globalization, a more rapid development of science and society depends on the innovations in the field of materials, technology, taking into account both current needs of economy and industry, and the effort to preserve the environment as a prerequisite for our survival, which makes the topics defined at the EEM 2021 Congress the more urgent. The engineering, environment, and materials in process industry is an opportunity for members of the scholarly community to exchange the results of their work internationally and gain insight into the possibility to applying their research results in the practice. Honorable guests, the EEM 2021 is the 7th scientific conference organized by the Faculty of Technology Zvornik, University of East Sarajevo. The conference was established exactly 12 years ago, and we are proud to say that so far almost 1,000 researchers and professionals from over 60 countries have taken part of the Congress with the over 1,300 submissions. However, we would not have managed to meet such a high standards without the help of the friends of the Faculty of the Technology and the EEM Congress. the institutions, companies, and individuals who have offered their kind support for this event. Therefore, we take this opportunity to extend our sincere gratitude to them. We are especially grateful to the Ministry of Scientific and Technology Development, Higher Education and Information Society of the Republic of Srpska and the Academy of Science and Arts of the Republic of Srpska, under whose auspices this event has been organized for 12 years. We would like to thank our general sponsors, Alumina Zvornik, the city of the Zvornik, Zeohem Zvornik, as well as our sponsors Rudnik i Termoelektrana Ugljevik, Zlatno zrno East Sarajevo, Student Prom Zvornik, Destilacija Teslić, 11. Mart Srebrenica, Orao Bijeljina, Regionalna deponija Zvornik, and numerous other sponsors without whose support it would be impossible to organize this event. We owe our gratitude to the Union of Engineers and Technicians of the Republic of Serbia, Faculty of Technology and Metallurgy in Belgrade, and Faculty of Technology Osijek for their help and support over the many years. We are also immensely proud to say that the team of EEM co-organizer has gained 2 new members this year, the Institute of Physics Belgrade at Serbia and the Moscow State University of Food Production, Russia, to whom we express our warmest welcome and gratitude. Sorry, I should take water. We are delighted to say that this year's event is supported by 2 international renowned scientific publishers, Springer Nature and Willy, who were kind enough to offer these scientific journals to research results presented here at the EEM2021. And we wish to express our gratitude to them together with other renowned EEM2021 supporting publication, as an applied science, Journal of Food Processing and Preservation, Health, Food and Biotechnology, Chemiska Industrija, and the Journal of Engineering and Processing Management. We would like to thank the organization endorsing the EEM2021, the European ISECI Food Association, which is an independent international non-profit organization aiming to establish cooperation in a food production chain, the European Federation of Chemical Engineering, and the COST Association, the oldest European Union program designed to promote cooperation and help connect researchers' initiative across Europe and beyond. I wish to express our sincerest gratitude to the members of the scientific committee and to the many reviewers who have put in a great effort in order for the papers to be ready for this event. We also wish to thank our hosts, the management of the staff of the Terma Hotel, who will make sure that our stay here for 3 days be pleasant as possible, as well as to the tourist organization Happy Travel Bijeljina for their technical supporting. We are especially grateful to our plenary lecturers and speakers, to those of you who decided to participate in the activities at the Congress, aware of the fact that presentations and the exchange of the scientific achievements is of key importance. We also owe our gratitude to all the associates and staff members of the Faculty of Technology Zvornik for offering their knowledge and experience in order to make this event possible, as well as to the media covering the activities of this gathering. Distinguished guests, ladies and gentlemen, we hope with your help this Congress will be successful and achieve its goals. We wish you pleasant stay on this beautiful mountain on Jahorina. In this beautiful weather, as a previous Congress, in this Congress is a bounty of the snow, so meanwhile, take the time and go outside skiing. Thank you all.
Thank you, Dean. And now let's move on. Ladies and gentlemen, Considering the current situation with the pandemic of COVID-19, the representatives of our esteemed institution, the Academy of Sciences and Arts of the Republic of Srpska, namely Honorable Professor Rajko Kuzmanović, the President of the Academy, was unfortunately unable to attend the opening ceremony. Therefore, please allow me to read the letter he has sent to the organizing committee and the chairman of the organizing committee. Thank you, Dean. Now, dear Dean Vujadinović, thank you for your kind invitation to address the conference at the opening of the 7th International Congress, Engineering, Environment and Materials in Process Industry, EEM2021, to be held on the 17th of March 2021 on the Jahorina mountain. The Faculty of Technology in Zvornik has become highly reputed for its good practice in organizing an international conference in its relevant scientific and professional field, not only the Republic of Srpska and Bosnia and Herzegovina, but across the region and beyond. It is evident that this 7th International Congress has been well prepared. Over 200 submissions from more than 30 countries is quite an impressive number, which stands in line with the goals of the Academy to spread science and research achievements internationally. The Academy of Sciences and Arts has had a good cooperation with the Faculty of Technology Zvornik so far, and will continue to find successful modes of cooperation between the two institutions in the future. I'm sorry to say that I will not be able to participate at the 7th International Congress, Engineering, Environment and Materials in Process Industry, EEM 2021, due to the current situation with the coronavirus pandemic. I'm positive that the Congress will be successful, and therefore I take this opportunity to offer you in advance my congratulations and best wishes for many new events to come. Yours sincerely, academician Professor Rajko Kuzmanović, President of the Academy of Sciences and Arts of the Republic of Srpska. So let's give Mr. Kuzmanović, Professor Kuzmanović, a thankful applause. Thank you. And now, on behalf of the general sponsor, Mr. Zoran Petković, General Director of ZEOCHEM DOO Zvornik, would like to address the conference. Let us give a warm welcome to Mr. Zoran Petković.
Dear guests, ladies and gentlemen, first of all, I would like to wish you a welcome to this mountain, and I would like to wish you a good afternoon before everything. My name is Zoran Petković. I'm coming from company ZEOCHEM. For those who are not aware of this company, we are existing for more than 200 years. We are generally located in Switzerland. Our head office is in Switzerland. And as I mentioned, for over 200 years, we are dealing mainly with chemistry. For the past 40, let's say 30 years, our main occupation is the production of molecular sieves, technical desiccants, and chromatography gels. A few years ago, we have established a production facility in Zvornik, together with our partner Illumina. And for, let's say, 4 years, we are producing all those products successfully and exporting them to all the countries in the world, all the continents in the world. These events as such, since we are the company which is, let's say, highly motivated in technology and everything, the events as such are the great support to our work. And company ZEOCHEM is involved in research and development very tight connections with Faculty of Technology and the institutions as such. I would like to say that the congresses as such are very big encouragement to the companies such as ZEOCHEM, and the engineers and the researchers, they are able to find on events like this important information, updated matters about technology, science, and everything. In the name of the ZEOCHEM, I would like to welcome all the participants, all the guests, and I would like to wish you a good stay here in this mountain, and I would like to wish you a successful work. Thank you.
Ladies and gentlemen, does anyone else wish to address the conference? If not, I now invite Assistant Professor Dr. Marko Gutelj, Vice Rector for International Cooperation and Quality Assurance of the University of East Sarajevo, to address the audience and open the Congress. Let us give a warm welcome to Vice Rector Gutelj. Rector.
Thank you very much. Dear organizer, dear colleagues and distinguished guests, I'm delighted to greet you all on behalf of the Rector of the University of East Sarajevo, Professor Milan Kulic, his team, and personally. University of East Sarajevo, in its program policy, strongly supports the organization of scientific and professional meetings such as this one. Faculty of Technology from Zvornik organizes international conference Engineering, Environment and Materials in Processing Industry for the 7th time, which proves that this conference is important not only for Bosnia and Herzegovina, but also for entire region. In addition, I would like to say that this meeting is classified as a leading international meeting according to the classification of the Ministry of Scientific and Technological Development, Higher Education, and the Information Society of Republic of Srpska. I'm particularly happy to be present at this event today because scientific committee, organizing committee, and all participants, all of you made a great effort to make this meeting happen, despite the problem connected with COVID-19 infection that all of us have faced with. International conference, engineering, environment, and material in processing industry have very important topics in the field of chemical engineering, food and material technology, and related fields. Moreover, this meeting will be a great opportunity to facilitate networking, information exchange, scientific cooperation between different universities, cooperation with public sector and civil society. Once again, thank you very much. I wish you very fruitful discussions and successful work. And now I would like to announce this conference, Engineering, Environment and Materials in Processing Industry Open. Thank you very much.
Thank you, Vice Rector. Ladies and gentlemen, with this we finish the opening ceremony. But before we start with the plenary sessions, let me remind you to adhere to the health and safety measures regarding the COVID-19 pandemic given by the health authorities. We now start with the plenary sessions, and I invited the moderators for the first lecture, Professor Genji Vaštag, Professor Svetlana Pelemiš, and Professor Dragan Vojinović to take over the management of the scientific part of the Congress and announce the first plenary lecture.
Thank you. First plenary lecture will be Professor George Dedousis, Horokopia, University of Athens.
We hope that Professor Dedousis is here.
I will read a short biography of Professor Dedousis. So let's start. George Dedousis is Professor of Molecular Genetics and Nutrigenetics and Vice Rector of Academic of Affairs and Quality Assurance of Harokopio University in Athens. He received his Bachelor of Science degree in Biology from the University of Patras, his Master's degree from the University of Technology Compiègne in France, and his PhD from the Medical School of Athens. He worked as a postdoctoral fellow at the Center of Thalassemia and as a researcher on a Fulbright scholarship and at the medical faculty of the Harvard University, Boston, USA. He has been a visiting professor for many years at the School of Pharmacy at the University of Nancy, France. As a principal investigator, he has coordinated a large number of research projects, mainly in the field of human molecular genetics, of cardiometabolic phenotypes, and their interaction with dietary intake. He has supervised 10 PhD students that have defended, while in 5 others, their dissertations are in progress. He has published more than 300 papers in journals with high impact factor, and his research work has been recognized by others, number of citations up to 50,000. In the period from 2018 to 2020, he was elected as Vice President of the National Research Council. He was nominated in 2019 among the most cited scientists worldwide during the last decade. He has coordinated many national and European grants in the field of genomics of obesity, myocardial infarction, and non-alcoholic fatty liver disease, NAFLD. Sorry. Thank you. He is also testing the potential beneficial impact of natural compounds on the clinical outcome of patients diagnosed with NAFLD, and he is the coordinator of a Marie Curie RISE European grant. His research group is consisted of nutritionists, biologists, and bioinformaticians.
Professor Dedousis.
Hello, everyone. Thank you for the introduction. Thank you for inviting me to your Congress. It's been an honor for me to be amongst you. It's a pity that I couldn't manage to come and be physically present in your lovely place. I've never been in Bosnia. It is one of my targets for the next coming years, and hopefully, if COVID will allow for that, I will find a chance to come and visit you. So I will start share. Well, it says that host disabled participant screen sharing. So someone has to allow me to screen share my presentation. All right, now it's better. So, great. I guess that you can see my presentation. So my presentation.
Yes, we can see,
Excellent. So my presentation is on mastiha treatment for obese with non-alcoholic fatty liver disease diagnosis, and the acronym of this European project is MAST for Health. I have to say that I'm coming from Kharkov University from Athens, a small university, and I'm a professor of molecular genetics and nutrition. So I will, in the next 35 minutes, I will present our story on mastiha. So I need to change. All right, so mastiha is a dried resinous exudate of stems and branches of Pistachia lentiscus, a shrub of the Anacardiaceae family, common in the Eastern Mediterranean area. The variety Chia is uniquely cultivated in the Greek island of Chios, and especially in the south part of this island. Chios is an island close to the border with Turkey in the east part of Aegean Sea. And in the south part of the island, we can cultivate this tree. And cutting on the shrub surface results to an actually congealing expression, possible due to a unique combination of climatic and ground conditions. And Chios mastigum has been characterized as a product of protected designation of origin in 1997. So here is myself 2 years ago among mastiha trees in Chios Island, and our previous president of democracy, Professor Pavlopoulos, visiting the island during the collection of the mastica tears, and you can see in the picture of mastica tear. So what's the chemical composition of mastica? Chemically, mastic gum is a complex natural product and consists of three categories of substances: the polymer, the volatile fraction, the essential oil, and the terpenic content. The polymer of mastic has been identified as a cis 1.4 poly beta methane, and its molecular weight matches up to 100,000 daltons. The mastica essential oil, which constitutes 2% of the total mastic content, it's the mastic oil, the product of the resins, and has a more intense and refined odor than the resin itself, with the A-theanine and vita-methane being the two major.
Sorry, Professor Dedus, because I'm breaking you, but we only see a title slide.
You can see the slide.
Yeah, we cannot see the slide. We only see the title slide.
Okay, so it didn't change to the second one. All right. What about now?
Okay, excellent, excellent, excellent.
All right, so I'll change from here.
Excellent. Thank you.
So I was describing the mastica in my first slide, so I apologize for this. So, and the island of Chios and the presence of our previous president of democracy during the collection of mastica. And then I was starting describing the chemical composition of mastica. So I was saying that there are three major constituents in the mastic gum: the polymer, the volatile fraction, and the terpenic content. And moving to the terpenic content, the terpenes in the mastic resin are classified into neutral and acidic. And the main constituents of mastic gum characteristic terpenic acids are the isomastica dienoic, briefly IMNA, and the mastica dienoic MNA. So these are the two major constituents of the terpenic product of mastica. So what are the biological activities of mastica that were known before our preparation and submission to the European community of this European project? So what we knew more than almost 20 years ago, from the first paper published in New England in 1998, the beneficial effect of consumption of mastic gum, even with a small quantity of 1 milligram per day for 2 weeks, it has shown that it can cure peptic ulcers very rapidly. But the mechanism responsible was not clear by that time. And the authors were able to show that the mastic was active against Helicobacter pylori, which could explain its therapeutic effect in patients with peptic ulcers. So the first action of mastica was antimicrobial. Second action of mastica was antioxidant. And from our group, colleagues from my department and others have shown and the antioxidant efficacy of Pistachia lentiscus supplement in IBD, inflammatory bowel disease, an inflammatory disease, and our colleagues were able to show the antioxidant efficacy of Pistachia lentiscus supplement. Other colleagues from different hospitals and university in Greece were able to show also the cardiovascular protective by showing the decrease on cholesterol and glucose level on healthy volunteers. And that was also a prospective randomized placebo-controlled pilot study. In addition, We were among the first showing the anti-atherogenic effect of Pistachia lentiscus, and we were also able to underline the mechanism behind the action of the bioactive molecules, which was via glutathione restoration and downregulation of CD36 mRNA expression. In addition, mastiha has been shown to be active as chemopreventive, and as it has been published by other colleagues showing that the extract from Pistachia lentiscus suppressed tumor growth in experimental colon cancer models. And finally, it was very much well known the effect of mastiha on the gastrointestinal system in the treatment of functional dyspepsia. So there were a lot of data available by that time, 5 years ago, showing multiple actions of mastiha and their constituents in health improvement. What about the bioavailability of mastiha constituents? We had recently published in Molecular Nutrition and Food Research that the two basic constituents of mastiha, the mastiha dienoic and the isomastiha dienoic, after injection were reached the maximum concentration in plasma 2 hours the mastiha dienoic and 4 hours the isomastiha dienoic after the injection. And more importantly, a few hours later, 4 to 6 hours later, we were able to show the maximum change in reduction of oxidized LDL due to the presence of the two major constituents. So we decided to target on a disease that was it is very common. It's called non-alcoholic fatty liver disease, which is the hepatic manifestation of the metabolic syndrome and frequently coexist with obesity, dyslipidemia, and insulin resistance. Actually, 1 out of 3 individuals in different populations across the world, we consider that he might be diagnosed with non-alcoholic fatty liver disease. So by definition, NFLD is defined as the presence of macrovesical steatosis in more than 5% of hepatocytes in individuals who consume little or no alcohol. And in a recent consensus meeting, it was concluded that significant alcohol consumption is defined as more than 21 drinks per week in men and more than 14 drinks per week in women over a 2-year period prior to diagnosis. And non-alcoholic fatty liver disease is histological further categorized in NAFL and non-alcoholic steatohepatitis, NASH. NAFL is defined as the presence of hepatic steatosis with no evidence of hepatocellular injury in the form of ballooning, as you can see in the picture, of the hepatocytes. And NASH is defined as the presence of hepatic steatocytes and inflammation with hepatocyte injury with or without fibrosis. So it is a continuous process, a progressive disease, which would start from a healthy liver, goes to a fatty liver, NASH, and then to a cirrhosis. So a percent of patients that have been diagnosed with fatty liver could progress to NASH, which is a worse disease, with or without fibrosis. And these first stages are very important because these stages are reversible. On the contrary, if it continues to cirrhosis, then it's irreversible. So given that there was no drug special for NFLD and NASH, we decided to design a trial with mastiha. So how can be done the diagnosis of NFLD and NFLD basically? The diagnosis can be done by modern imaging methods like ultrasound, computer tomography, and magnetic resonance, what's called MRI. And due to cost availability and easy performance, ultrasound is considered as the most frequently used method in diagnostics of NFLD. However, it should be kept in mind that the result of an ultrasound evaluation largely depends on the quality of the devices and subjective interpretation of the physician performing the test. So the gold standard method is the liver biopsy, but liver biopsy is an invasive method, still remains the reference standard for diagnosis of NASH and staging fibrosis, but it is avoided by the clinicians as well due to the side effects that they may produce. So in 2015, we were able to receive funding from European Commission due to a proposal which is called Must for Health Consortium, a multi-center randomized and double-blind placebo-controlled clinical trial aiming at testing the effectiveness of a herbal supplement with mastiha in non-alcoholic fatty liver NASH disease. The consortium is consisting of 15 partners, 9 academic and 6 non-academic from 8 countries. Among them, there were 3 clinical trial centers, one in Greece in Athens, the other in Italy, in Milano, and the third in Serbia, in Novi Sad. So the herbal supplement was designed to be administered in the form of capsules, either mastiha or placebo, cornstarch capsules, weighing 0.35 gram each, in 3 equal doses daily, in total 2.1 gram. And the verum and placebo capsules had identical appearance and organoleptic characteristics. The inclusion criteria were male or females with a confirmed diagnosis of NFLD NASH, and that was done by MRI and a technique that was applied by one of our partners in UK, which actually had developed a score. The score is called LIF score, liver infiltration score, a metric of inflammation and fibrosis. So a non-invasive technique which could be applied and assess the NASH stages, and all patients were adults, obese, BMI more than 30, and had a LIF score either more than 2 or a LIF score more than 1, with more than 2 slices with a LIF 2 to 4. So the primary endpoint of the intervention trial showed the improvement of liver histopathology as depicted in LIF or CT1. And secondary endpoints were alterations in biochemical markers the metabolomic profile, gut microbiome in response to mastiha treatment. So this is a figure of the whole trial. In the first instance, patients were invited to participate, assessed for their eligibility, 147 patients, excluded 49, for non-meeting inclusion criteria, declined to participate or other reasons, and randomized in the 3 clinical centers, 98 patients. Can you see my presentation?
Yes, we can see.
Okay, great. So the 98 patients were allocated in 2 groups, allocated to mastiha intervention, 41 patients, or placebo, 57. Follow-up for 6 months, either with placebo or with mastiha. Double-blind the intervention trial, so no one knew in advance what kind of capsule was taken, and analyzed after 6 months by the different groups. So, as I said, there were 3 clinical centers, 38 participants from Greece, 30 from Italy, and 30 from Serbia. These are the pictures that come out from the MRI with the installed program of Perspective, which is the partner, the UK partner that has applied this software, and the leaf score. So you can see that depending on the color, a green color shows liver with no fibrosis, and the yellow to orange and red, it's a scale from mild fibrosis to severe fibrosis. So these are the descriptives of the trial. As you can see, don't go to the numbers, just to show that there were no statistically important measures to every measure that we used, anthropometric, biochemical, clinical measures. There were no difference as expected between the 2 groups, the placebo or the mastiha, which was good, what was expected to happen. And this is the first result. Actually, this is the results that come out. It's a figure from our very recent publication in Molecular Nutrition and Food Research, actually last month, which shows that there was a decrease in the primary outcome that was designed, which was CT1 or leaf score, not to the whole group of patients, but especially, as you can see, when we stratify the patients by 2 BMI groups, those with low BMI, lower than 35, and those that had the BMI more than 35, so the very obese patients, the patients that received the mastiha supplement show a decrease, and statistically important decrease of the clinical parameters, which was a very good result related to the mastiha supplementation. So apart from the primary endpoint, we follow up with the secondary endpoints to identify the mechanism behind the effect of mastiha. So for receiving plasma samples, we extracted from plasma samples the constituents, the basic terpenoid constituents, MNA and IMNA, to verify that those receiving the mastiha supplement had a high concentration of these two major constituents. And we also proceed with an analytical method for measuring different small metabolites. And this was actually performed by a partner from the Department of Pharmacy in Athens. And the first analysis of the results, the clustering according to country. At first, the principal component analysis method was employed in order to detect any possible trends among the various sample classes. And from an initial point of view, there were no clear classification among the different sex, female, male, and study groups, mastiha or placebo. But interestingly, there was a trend among samples from different countries of origins. You can see that there are more similarities between Greek and Italians comparing to Serbians regarding to the metabolites in plasma. And also we observe here by clustering according to A or B. A was the axis taking mastiha, and B the capsule, the verum, the placebo. So you can see that there are different clusters of metabolites showing that indeed there was a difference in responding depending of taking capsule, mastiha or placebo. And when we measure different metabolites, as you can see here in this figure, we obtain levels for 65 annotated metabolites. Metabolites show no difference post-treatment between the two groups in the main model, adjusted for the baseline metabolite level, age, sex, and center, apart from the titerpenic acid sulfate. So the patients taking the A capsules with marked A was actually patients taking mastiha. Indeed, so the results proved that there was a compliance. So the patients were taking the capsules since we identified the major constituent of mastiha. But in addition to this basic titerpenoid, we also were able to identify several metabolite levels significantly decreased in mastiha compared to placebo. And these were the lysophosphatidylcholine and lysophosphatidylethanolamine after adjusting for the corresponding baseline metabolites, age, sex, center, and difference in caloric intake. And similarly, in mastiha group, folic acid decreased significantly compared to placebo after adjusting for various factors. Moreover, we performed the analysis of gut microbiome by extracting DNA from fecal samples, sequencing 16S ribosomic RNA and sequencing. And this was done by our partner in Valencia. And first, when we analyzed and compared the initial microbiota at time 0 from each country, we observed that both alpha diversity and beta diversity are significantly different between countries. Again, there were some similarities between Greek and Italians regarding the different microbiota populations, comparing to the Serbian populations, although there were some similarities between all three populations, but more similarities were found between Italians and Greeks. And when we analyze the results before and after treatment, it can be shown that those taking mastiha, there was an increase in both dissimilarity indexes, showing that there was an increase of heterogeneity, an increase of different microbiota populations after mastiha intervention. And this was obvious in 3 countries, in Greeks and Serbian and Italians, although separately was not found statistically important, but in total, when we analyzed them, the whole group, it was found that there was a significant difference between the microbiota markers in the whole population. And this was actually found here, that we identified different microbial population in an increase, as I said, in the group taking mastiha comparing to the group taking placebo. And that was, and on top of that, it was very important to show similar results in mice, since our group, Sanofi and Aimo Khan, the coordinator of this intervention trial in mice, showed similar results. And actually, they feed mice to become obese and have a similar picture as the non-alcoholic fatty liver disease. And a group of mice were taking mastiha for 8 weeks. And actually, they found that there was no increase, no difference in body weight, no difference in total calorie intake, but there were difference in plasma ALT measures, which actually a biochemical indices of hepatic steatosis. So you can see that there was a decrease in ALT levels in mice become NFLD after taking the mastiha supplements. And this was statistically important. And also there was a decrease in liver total cholesterol and decrease in the total liver weight, and also a decrease in collagen and galectin 3 in those mice taking mastiha. And these results confirm actually our results in human. And the same standard for after the microbiota analysis, showing an increase of diversity of the gut microbiota at different sequence coverage. So the microbial diversity was partially recovered under mastiha supplementations. So there was a publication last year in New York Times, Can this ancient Greek medicine cure humanity? I'm not in a position to give any answer, but the results are very promising. And there are other efforts from my group to study further the mechanism behind the action of mastiha, and in other entities, health entities like hypertension. And there is actually a program that is in progress looking on the benefit, the potential beneficial effect of mastiha as an antihypertension drug. So this is the first picture during our first meeting in Athens, in Kharkov University. I have to say again that this proposal was funded under the Marie Curie Action, Marie Curie Rise, and different pictures from mastiha, mastiha 3, The final meeting was held in Chios Island last February, a year ago, just before COVID pandemic. So we were very lucky. We had the chance to meet together in this beautiful island. And these are different pictures from our meetings in Italy, in Pisa, and the island of Chios. So I would like to thank you very much for your attention. I'm open for questions, discussion.
Thank you, Professor Redoussis. Any questions, please?
No. Is there anyone online to ask the questions? Is there any raise the hands? No. Just from me, Professor Redoussis, what would you suggest to us? Do we have to use mastica as a supplement, food supplement in the everyday diet or not? What is your opinion?
So my opinion is that first, I would strongly recommend you to visit Chios Island for those who have done so far. So that's a very nice destination for summer vacations. So apart from this, mastica is available online as well, mastica capsules, and it has shown many beneficial and preventive actions for different cardiometabolic phenotypes. So there are no side effects. You can take it even for dyspepsia. So after a heavy meal, mastica is the best supplement to take it. And it smells very good. It can be used either for making sweets, but definitely mastica has attracted the interest from many partners across the world and drug companies to extract the major constituents and use them as a drug. So that's my advice.
Thank you, Professor Redoussis. Any questions now? No?
Thank you very much.
Thank you. Have a nice evening.
Have a nice evening.
According to agenda, now it's short coffee break, 15 minutes. We are starting again at 17 o'clock.
degrees from the Faculty of Chemistry and the PhD degree from the Faculty of Technology and Metallurgy, University of Belgrade. Since 1995, she joined the Radiation and Environmental Protection Department of the Vinča Institute of Nuclear Sciences, National Institute of the Republic of Serbia, University of Belgrade, and currently is a Principal Research Fellow. She developed a broad interest in material science, sorption processes, wastewater treatment, environmental engineering, waste management, characterization, and valorization during the scientific career. She conducts experimental and theoretical research related to the characterization of natural, synthetic, modified materials and waste and byproducts from different industries as solid matrices for the separation and stabilization of heavy metals and radionuclides. The emphasis is on the applicability of apatite-based materials, synthetic powders with tunable properties, and biogenic apatite obtained by animal bone processing. Her research is lately directed on the factors of their complex interactions governing pollutants association with various soil fractions, the efficacy of different unconventional, low-cost and recycled soil additives to stabilize heavy metals and radionuclides in situ, the safety of their use, and prospects to improve essential soil properties. In 2019, her group received the annual award of the Vinča Institute for Applied Research. Dr. Smičiklas continuously participated in projects financed by the Serbian Ministry of Education, Science and Technological Development. In the period from 2011 to 2019, she organized and coordinated a multidisciplinary team of researchers through the integral and interdisciplinary research project, sub-project management. Internationally established cooperation includes leadership and participation in bilateral projects and participation in projects financed by the IAEA, Croatian Science Foundation, and COST. She supervised 3 PhD candidates and is presently supervising 1 PhD student. The scientific output includes over 60 papers in international peer-reviewed journals, 3 book chapters, and 70 presentations at national and international conferences, including 3 invited lectures. Without self-citations, the publications have been cited 1,560 times, H index 18. She was an invited reviewer in over 20 journals from the SCI list and a member of foreign and national conferences, scientific communities. In the field of science promotion and popularization in Serbia, she was active as an organizer and lecturer in a dozen projects, workshops, and manifestations intended for high school students.
Thank you very much. I'm addressing you from Belgrade with regret that I'm not with you at Jahorina Mountain. I wish firstly to express my thanks to the organizing and scientific committee for this invitation and to wish you a very successful meeting. I will now share my presentation with you. This presentation will be about the possibilities of valorizing secondary sources of phosphorus, and it will be the story about the possible use of biological apatite in the soil remediation and rehabilitation. With this review, I aim to emphasize 2 important environmental issues, such as soil contamination and animal waste as a high-risk issue, and to connect them in the circular pattern. The soil degradation is a global and very significant problem. It means that the quality of the soil is reduced in order to provide ecosystem services and functions. And by contemporary society and by increased pressure on to increased agricultural production and industrialization and urbanization, the soil is endangered nowadays. This threat was recognized by the United Nations, And one of the Sustainable Development Goals of the United Nations is to protect, restore, and to promote the sustainable use of all terrestrial ecosystems. In the European Union, the problem is also huge. The major threats to soil quality are, for example, sealing, erosion, desertification, acidification of the soil, and of course, soil contamination. The contamination of the soil is a particular mode of degradation because it acts as a trigger for other degradation processes such as erosion and the loss of biodiversity. According to the GRC, in the European Union, there are over 650,000 sites with registered polluting activities. And among these sites, the most frequent contaminants are exactly heavy metals and mineral oils. The size of the problem in the European Union is also huge. More than 28% of the total surface area of the European Union shows exceeded concentrations of either one or more heavy metals. And what's more concerning is that over 6% of agricultural soil in the European Union also shows elevated concentrations of heavy metals. In the Republic of Serbia, in our registry of potentially contaminated and contaminated sites, there are over 700 entries. And on this slide, we can see the investigated industrial sites over the territory of Serbia, which show elevated concentrations of heavy metals. Currently, there are many methods to reduce the toxicity and the risks from heavy metals in the soil, including physical, chemical, and biologically facilitated methods. I will emphasize the prospects of in situ heavy metal stabilization in the soil. This is the so-called gentle remediation technique because the contaminants are not physically separated from the soil matrix, but their mobility, solubility, and toxicity is reduced. This is done by changing heavy metals' chemical forms in the soil by application of appropriate chemical additives or reactants. And since they have to be mixed with the soil with appropriate mechanization, this technique is practical in cases where the contaminants are in the upper layer of the soil. They can also be introduced in the soil in the form of the suspension. But using this technique, the major soil properties are preserved. The soil can be used after the treatment for various purposes. And this technique has very low impact on the local community. Also, we can be cost effective and sustainable, particularly if sustainable materials are used in the remediation process. The method is also rapid and with the very low level of secondary pollution. Of course, before and after the remediation, environmental risk assessment must be made, and it is done using physical, chemical, or biological tests. Most often, the single extraction tests are carried out. For example, the US EPA toxicity characteristic leaching procedure or other methods. And the aim of this method is to validate only the fraction of metals in the soil that can be leached out from the soil under certain operating conditions. There is also another approach for evaluating the metal mobility in the soil, and this is by using sequential extraction protocols. Today we use, for example, so-called Tessier extraction protocol or the BCR protocol, which was developed by the European Community Bureau of Reference. These methods are more time-consuming, but they allow us to differentiate various fractions of metal and to assess their association with different components of the soil matrix. This is the example of the Tessier extraction protocol, which consists of 5 stages. In the first stage, we extract only the metals that were binned by ion exchangeable reactions with the soil constituents. In the second phase, we extract using mild acids the fraction of metals that was associated with the carbonate phase or hemisorbed. In the third fraction, we extract the elements that were occluded by the oxides of iron or manganese. In the fourth fraction, we use the oxidizing agent. We destroy the organic phase and liberate the metals that were complexed with the organic matter. And in the fifth, the last fraction, we use concentrated acids and liberate the metals that were incorporated in the crystal structure of the soil minerals. And we can say that along the steps of the sequential extraction, the stability of metals in the soil increases. And the aim of in situ remediation methods is to induce the redistribution of pollutants from more mobile to more stable soil fractions, preferably to the residual fraction. In the process of metal stabilization in the soil, various amendments are added to the soil. For example, carbonate, phosphate compounds of various kinds, natural minerals like zeolites, clays, or iron-containing minerals, then alkaline agents such as lime, for example. And in recent years, various waste products and byproducts from various industries are being examined as soil additives for metal stabilization. Of course, the selection of an appropriate agent is a specific and process that needs holistic approach. All site-specific parameters must be taken into account, including the type of the pollutants, their concentration, the properties of the soil, future use of the soil, and so on. Among these additives, phosphate additives are very compelling for metal stabilization because all heavy metals form insoluble metal phosphate phases. They are thermodynamically stable under environmental conditions, and this is the feature that can ensure the long-term immobilization effect in the soil. The firms that perform in situ stabilization remediation methods often use calcium phosphates such as monocalcium, dicalcium, tricalcium phosphates. These are soluble compounds, but they also use the hydroxyapatite and apatites of various kinds, which are moderately soluble, and as such they display particularly good results in heavy metal immobilization because the short-term leaching of phosphates is reduced by using such products. The apatite compounds are very specific. This is the formula of the calcium hydroxy apatite, but this is the very large group of minerals with one general formula, because the crystal structure of the hydroxyapatite is very prone to both cationic and ionic substitutions, and practically all the elements from the periodic table, including heavy metals and radionuclides, can be incorporated in the structure of the apatite. Calcium apatite also shows thermal stability, high specific surface area, porosity, buffering properties, which is applicable in soil, and the ability of calcium apatite to bind cations is beneficial in terms of their separation and stabilization. So these materials can be used in the water treatment processes, in soil remediation, and also in the protection and the treatments of the subsurface water. Apatites can be generally divided into the synthetic ones and the natural ones. Synthetic can be, of course, obtained with high purity and with tunable properties. However, these synthetic procedures are expensive for the product to be used in the soil. Natural apatites can be divided into geologic and to biogenic. Geological deposits of apatite, or so-called phosphate rock, is the primary source of phosphate. It is used for the production of all phosphate compounds, and it is characterized with very low solubility and very often elevated concentrations of some toxic elements, for example, cadmium and uranium. On the other hand, we have the biogenic apatite, which is the secondary source of phosphorus. It can be found as a mineral phase of animals and fish bones and teeth. It has moderate solubility, which is preferable for soil application, as well as low concentrations of potentially toxic and toxic elements. Now we come to the problem of the significance and scarcity of phosphorus in the environment. Today, more than 40% of the world's soil are deficient in phosphorus, and this led to the increased demand for phosphate fertilizers. And as a consequence, this led to the depletion of the primary source of phosphorus, or the phosphate rock. There is also an uneven distribution of the phosphate rock among the continents. So specifically, European continent strongly depends on the imports because it lacks rich phosphate deposits, and the phosphate rock is now on the list of critical raw materials in the European Union. The situation in the Republic of Serbia is as in the rest of Europe. First of all, the central part of our country is characterized by soil types with very low or low content of easily accessible phosphorus, and Serbia also lacks phosphate deposits. So the problem of phosphorus scarcity can be mitigated only by increasing the efficiency of use and efficiency of reuse of the phosphorus. And last year, the European Commission has adopted a new circular economy action plan. According to this plan, the biological resources will represent a major input to the economy of the European Union. It was also estimated that between the production of fertilizers and the consumption of food, about 80% of phosphorus is lost. And along this chain, phosphorus can be recovered from various wastes and byproducts. Of course, not all the wastes are viable sources of phosphorus, but for example, animal bones exhibit 10% of phosphorus on average. And according to the Waste Framework Directive, eco-friendly materials can be obtained from such a waste. Animal waste is another huge problem over the world, in Europe and Serbia in particular, because the disposal of animal waste is associated with high costs and with health risks. So the valorization of animal waste is one significant task for the contemporary society. It was estimated that in the European Union, over 50 million tons of carcass weight animals are slaughtered yearly. And in this quantity, over 4 million tons of bone biomass is produced annually in the European Union. The European Union has a regulation which specifies, first of all, it categorizes the animal waste into 3 categories according to the level of the risk. And also this regulation specifies all the necessary procedure for the segregation, disposal, treatment, or possible use of animal waste. In order to be used in the soil, in the form of organic fertilizer or soil improver, the product from animal waste must be obtained from category 2 or category 3 materials, and it must be subjected to the prescribed methods of treatment before use. Animal waste in Serbia is a huge problem. We have over 900 plants for cattle slaughter and meat processing in Serbia, but the data about the amounts of waste that is generated in Serbia are very scarce and outdated. I could find only the data from 10 years ago, according to which we have about 245,000 of slaughterhouse waste. And what's more concerning is that only or less than 20% of this waste is processed in the rendering plants, and the other quantities are being buried or disposed on the illegal landfills without any pretreatment. Serbia has the waste management strategy for the past 10 years. And although the problem of animal waste management was highlighted in this strategy, unfortunately, nothing much has been done in practice. And last year, a new program for improving the management of animal byproducts is adopted in Serbia. Now I will highlight some specific properties of the bioapatite from bone and why is it so interesting for soil remediation. Bone is the natural composite. It is made of organic phase, namely the protein collagen, which is fibrillar, and inside these fibrils, the mineralization of the bioapatite is taking place. So the connection between the organic and inorganic phase is very tight in the bone. In the Institute of Vinča, our group has performed some experiments with the cow bones, and thermal gravimetric analysis have confirmed that about 60% of the bone total mass is the bioapatite, 32% is the organic phase, and the rest is the water. If we look at the morphology and the crystal structure of the bioapatite inside the bones, we can see that the crystals are needle-like. They are of nano size with 5 to 10 nanometers in one direction and 30 to 50 nanometers in the other direction. But although very tiny, these particles are crystalline and they show the characteristic crystal structure of the hydroxyapatite. The bioapatite recovery from the bone can be made by various treatments, including thermal treatments, such as thermal oxidative treatments or pyrolysis, then by implementing chemical treatments in order to destroy or to extract the organic phase of the bone. There are also some sophisticated methods for organic phase removal. But the viability of these treatments is being assessed based on the properties of the final products and their future use, because the bioapatite recovered from animal bones can be used in various fields of industry and technology and science, and also in medicine, dentistry, waste treatment, soil remediation, and so on. In order to be applied in the soil as an additive, the material must be available in very large amounts, in tons, and this is one of the key attributes of the material to be used in the soil. So waste processing methods for animal waste must be scalable to an industrial level and must be economical and with a low amount of secondary waste and pollution. For the soil products, animal waste is subjected to the pasteurization or sterilization. It could be subjected to thermo-oxidative treatments and pyrolysis, and this is currently the most promising methods for obtaining the bioapatite products for the use in the soil. Among them, Thermal treatments have advantages in terms of simplicity, first of all, then lower health risk, well-regulated conditions during the treatment, and the possibility to treat very large amounts of the waste at one time. Our group has performed experiments regarding the temperature during the thermo-oxidative treatments of the cow bones. We have applied various temperatures. We have obtained the products with very different characteristics. These products were analyzed by chemical and instrumental analysis, and what we could conclude is that the organic phase of the bone is destroyed at 400 degrees Celsius and at higher temperatures. But the product that was obtained at 400 degrees Celsius have the low crystallinity, similar as the original bone, while with the increase of the temperature, the agglomeration and the sintering of bioapatite nanocrystals is taking place, and the obtained product has much higher crystallinity. As a consequence of higher crystallinity, the products obtained at elevated temperatures has much lower specific surface area than the product that was obtained at 400 degrees. This is the physical appearance of these products, and it can be seen that the product at 400 degrees is gray due to the carbonization of the organic phase. However, in our work that was conceived after that, we have examined the capacity of these materials to sorb heavy metals and radionuclides, and it was confirmed that the product which exhibits the highest surface area in the same time is the high capacity sorbent for various heavy metals and radionuclides, and the conclusion was that the mild temperatures of about 400 degrees are optimal for obtaining the material with the highest metal removal capacity. Another way to obtain biochars for implementation in the soil is pyrolysis. I have highlighted the results of the Nutriman project, which is conducted under Horizon 2020. During this project, an advanced and zero emission system was developed to process food-grade animal bones and to produce a very high quality animal bone char out of this waste. This char has 92% of pure calcium phosphate. The safety criteria for the use of such product are satisfied in terms of very low concentrations of potentially toxic elements and also of persistent organic pollutants. And this product is intended to be used in the European market as an innovative phosphate fertilizer. When the bioapatite is added to the soil, several changes in soil characteristics can be observed. First of all, we have a slow release of phosphates from the bone char. Then the buffering properties of bone char are taking charge, and the increase in soil pH value can also be detected. And as a consequence of these changes, we can always detect the reduced metal mobility, bioavailability, and toxicity. Various studies on the use of the bioapatite in the soil remediation point to the major factors that influence the efficiency of this process. First of all, the raw material type or the type of bones that we use for this purpose, then the raw material processing conditions, then the rate at which we use the bioapatite in the soil, then the properties of the soil itself, and of course the type of the pollutant and the concentration of the pollutant in the soil. If we compare the bone meal and bone char as diverse products. The bone meal is a commercial product that is obtained by crushing and sterilization of animal bones. So it still contains about 30 to 40% of organic matter. In various studies performed at soil from historic mining sites, this material was found to decrease the mobility of, for example, lead and zinc and copper in these samples, and it was confirmed by single extraction analysis in soil with different characteristics, including the pH value. However, the medium-term studies and long-term studies have indicated that this organic fraction of bone meal can undergo breakdown in the soil, and the weak organic acids that are formed during this process can form organometallic complexes and even increase the mobility of heavy metals in the soil. So if we have to choose between the bone meal and bone char, the bone char is a much better choice for metal stabilization. Also, the type of pollutants affect the immobilization efficiency and the dose of the bone char in the soil. This is the example of the experiment conducted in our group. The bone char was added at different amounts of 1 and 5% into an acidic soil, which had simultaneously elevated concentrations of copper, lead, and nickel. After 2 months of incubation of this soil with bone char, we have performed a sequential extraction analysis, and we revealed the distribution of metals in the original soil and after implementing the various doses of the bone char. It could be seen that in all cases, this red bar, which represents the ion exchangeable fraction of metals, which is most mobile and toxic, have decreased after the implementation of the bone char. Also, this decrease was connected with the bone char dose for every cation. However, the efficiency was not the same for all cations. The lead was most efficiently immobilized, and it was practically transferred from the ion exchangeable to the residual fraction, and then the effect was pronounced for copper and then for nickel. So the type of pollutants must also be taken into account when the remediation technique is developed. Then the effect of the bone char depends on the properties of the bones, and a great difference was detected between fish bones and the bones of other species that were examined, for example, cow bones, pig bones, or chicken bones. Fish bones exhibit especially poor crystallinity and especially high internal porosity, which make them very reactive, and this induces the precipitation of metal phosphides. Near the coastline areas, where seafood industry is developed, fish bones represent a very low cost and available source of the apatite. There is a product named apatite 2. It is the commercial product, and it can be used for the remediation of lots of heavy metals, and its efficiency was demonstrated on the full-scale technology demonstration. Then we have investigated the effect of the soil type on the efficiency of remediation. These are the results from our group. They are performed using 8 different soil types, which are characteristic for the Republic of Serbia. These types have very distinct physical-chemical properties, and we have contaminated them with the same level of cadmium and introduce 2% or 5% of the bone char. And after 2 months of incubation, the sequential extraction of cadmium in the soil was performed. What we could conclude is that the ion exchangeable fraction of cadmium decreased in all soil types. However, the effect was very different in different soil types. The exchangeable fraction of cadmium was decreased by a maximum of 46 and 52% with the doses of 2 or 5% of the bioapatite. And we also performed the correlation of the soil properties with the effect on cadmium immobilization and found a very significant correlation between the initial pH value of the soil and the immobilization effect of cadmium. It is known that the bone char effect on metal stabilization is closely related to the bone char solubility in the soil. This reaction globally presents the dissolution of one carbonated substituted calcium phosphate in the presence of the acidic medium. This reaction also explains the buffering effects of the hydroxyapatite, which relies on the phosphate system. And a study on bone char applicability as a phosphate fertilizer in the soils of different types, has revealed that the dissolution of bone char varies from 0 to even 73% in connection with the pH value of the soil, and that the dissolution is not significant in the soil that has a pH value higher than 6. So acidic soil are more prone to increase the reactivity of bone char and to induce higher immobilization effect. There was also a study in which the bone char effect on metal stabilization, in this case cadmium stabilization in 11 different soil types, was compared to the effect of the triple superphosphate, or this is the conventional phosphate fertilizer. It was concluded, first of all, that the bone char solubility is always lower than the solubility of the TSP. But on the other hand, the effect on cadmium immobilization was higher by a factor of 1.4 to the factor of 2.7 using the bone char. And this study had revealed that the bone char can be used for the rehabilitation of the soil as an innovative phosphate fertilizer and also as a superior immobilization agent for cadmium. The mechanism by which the various metals are stabilized in the soil is different for particular heavy metals. There is a reason why the lead is most efficiently stabilized in all soil types. Namely, this can be explained by the large difference in the solubility of the calcium phosphate and the lead phosphate. And this difference acts as a driving force for the dissolution of calcium apatite and for the precipitation of the lead apatite, which is called pyromorphite. The mechanism of the stabilization of other cations, for example, zinc, cadmium, nickel, cobalt, very much depends on the properties of the soil and on the concentration of the element in the soil. Chemisorption can occur both on the bioapatite and on other components of the soil. And then the complexation, ion exchange, and especially if metal concentrations in the soil are very high, the precipitation of new phosphate phases was detected using instrumental analysis. So all these studies conceived so far have confirmed that bioapatite is a versatile heavy metal stabilization agent, as it can act as a stabilizing agent for various pollutants in the soil. However, there are some limitations. First of all, it is the arsenic, which is present in the soil in the form of the oxyion, and competitive interaction may occur between the phosphates and other oxyions, so their mobility may be even increased after the application of the bioapatite. The benefits of the use of bioapatite in the soil are numerous. First of all, we manage and treat and reduce the animal waste, which is a huge problem. we recover the phosphate. During the thermal treatments of animal waste, energy can be recovered also. And by all means, we protect the limited geological deposits of the phosphate rock. Then sustainable materials, eco-friendly materials are obtained, which can be used both as a soil fertilizer and agent for the remediation of metal or radionuclide contaminated soil. However, there are also major challenges in implementing such technology. First of all, the lack of toxicity of bone-based products must be assured. This must be done by conducted chemical and ecotoxicological tests using these materials, and if they not comply with the standards, the process conditions must be modified, processing conditions of the animal waste. Then the metal stability over long periods of time must be verified, and it is conducted by long-term monitoring programs on the remediated sites. And if the lack of stability of metals is detected, then repetitive treatments must be done. Then we have the risks of leaching of phosphorus from soil, especially if heavy doses of bioapatite are added to the soil. And this can also induce the decreased bioavailability of essential heavy metals that are needed for plants. This means that a site-specific approach for every particular case of contamination must be conducted in order to prevent or to minimize such risks. And of course, the improvement of the effectiveness of the method is always welcome. And this could be, in this case, done by using other reactive materials in addition to the bioapatite in the soil, or to combine the in situ stabilization method with bioapatite with other remediation technologies. This is one of the examples from our group. These are preliminary results where we combine the addition of the bioapatite to the cadmium contaminated soil, and we grow the tobacco plant on this soil with or without the additive. What we concluded is that the concentration of cadmium in the tobacco plant is reduced after implementing the biochar to the soil, which means that a biochar effectively stabilize the cadmium. However, this concentration is still very high, which means that tobacco plant is the hyper accumulating plant for cadmium, and such plants can be used to extract the residual mobile fraction of the heavy metals from the soil, in addition to heavy metal stabilization. And to conclude, these are some unpleasant scenes from Serbia, from our newspapers. On our way to joining the European Union, we need to put a lot of effort in order to change these practices and to invest more in the reduction and separation and recycling of animal waste. So this presentation aimed to emphasize possible innovations in the field of animal waste treatment and reuse, especially in Serbia. That would be all. I thank you for your attention.
Thank you, Ivana. Is there any question about this lecture? No? Yes. Okay.
Microphone, please.
I have problem hearing you.
Ivana, 1, 2, 3.
Yes, I hear you now.
Good, nice. This is Susanna from Faculty of Natural Sciences in Banja Luka. We liked very much, of course, your presentation, and thank you for dealing with such an important problem. For
Thank you.
Bosnia and Herzegovina especially, it's a huge problem. Chicken waste, you know, we're a chicken kingdom now with 50 millions of broilers slaughtered every year, especially. But I would like to pose you a short scientific question regarding the methodology of pyrolysis which you used, calcification actually. You showed us this very nice increase in specific surface at 400 degrees. So I just would like to know which gases do you use? You just simply burn it in the ordinary...
Yes, in the oxygen atmosphere.
It is
it's not a pyrolysis, it was the thermo-oxidative degradation of the organic phase.
Okay. So you do have an oxygen flow?
Yes.
Okay, this is important point. You didn't switch gases or try some more
we didn't have that experimental capabilities in the institute, but this is the plan to do so. But we also have to bear in mind that this process needs to be a low-cost process.
Yeah, sure. Thank you very much. It was really interesting.
Thank you.
Thank you. Any questions, please? No. So, thank you, Ivana.
Thank you.
Today, activities.
Now I invite you for the cocktail again.
For all for all participants, we are sorry. Next time. Okay.